Hey guys, today we are looking at section 3.4, which is implicit differentiation, part 1. So sometimes you're going to have equations where you cannot get y by itself, so you cannot isolate y in terms of x or one variable, so then you're going to take the derivative implicitly. So what that means is step 1, take the derivative normally, but each time a y is involved, you have to apply the chain rule, which means each y must be tagged with a dy dx or y prime. So if I'm starting with y squared plus 3x is equal to 5x cubed. Well, if I have y squared, the 2 is going to come down in front, so I'm going to have 2y. But because I took a derivative with a y, I've got to put a dy over dx with it. Then the derivative of 3x is plus 3. And if I have a 5x cubed, the 3 comes down and it's 15x squared. So anytime you take a derivative that has a y, you've got to put in that dy dx. So now what I'm going to do is I'm going to get all the terms with dy dx on the left side and everything else going to be on the right side. So if I have 2y dy over dx plus 3 is equal to 15x squared, what I'm going to do is I'm going to subtract 3 from both sides. So 2y dy over dx is equal to a 15x squared minus 3. And then from there, I'm going to divide both sides by 2y. So what you're trying to do is factor out dy dx or y prime if necessary to create only one dy dx or y term, and then solve for that dy dx. This time we don't have to factor it out, so I'm just going to divide by that 2y, and I get dy over dx is equal to a 15x squared minus 3 over 2y. And that is our derivative. That's our answer there. So let's look at some more examples. Let's get some more practice with this. So number 1 right here, I've got y cubed, so I'm going to bring that 3 down in front. So I'm going to have 3y squared, and then I got to put a dy dx because there's a y. Then the derivative of negative 3x is going to be negative 3. It's equal to, I'm going to bring down that 4x cubed, plus, well, the derivative of 2y is 2, and because it was a y, I've got to do a dy dx. So let's move all the dy dx terms to the left and the non-dy dx terms to the right. So I'm going to add 3 to both sides. So 3y squared dy over dx is equal to 4x cubed plus 3 plus 2 dy over dx. And then I need to subtract that 2 dy over dx. So now I'm looking at 3y squared dy dx minus 2 dy dx is equal to 4x cubed plus 3. And this is that step 3 that I was talking about on that last example. I'm going to factor out a dy dx over here. So dy over dx times 3y squared minus 2 is equal to 4x cubed plus 3. And then all I have to do from here is divide by that 3y squared minus 2. So dy over dx is equal to 4x cubed plus 3 over 3y squared minus 2. And that is our derivative. So let's look at number 2. For number 2, I've got a 3x squared, so the 2 comes down in front, and that becomes a 6x. And then if I'm looking at this one right here, I have a 4xy squared, so I'm going to have to use my product rule. So I'm going to take the 4x and multiply it by the derivative of the y squared, which is 2y. And because it's a y, I've got to put that dy dx. And then plus, well, the derivative of 4x is 4, and then I take the second one and leave it how it is as a y squared. Then I'm subtracting my derivative here, so the 3 comes down and it becomes a 15 and then x squared. And remember, the derivative of a number is always just 0. So the derivative of 10 is just 0 there. So let's clean this up a little bit. I've got 6x plus, well, 4 times 2 is 8xy dy dx plus 4y squared minus 15x squared is equal to 0. So what I'm going to do here is I'm going to keep my dy dx on the left and move everything else to the right. So I'm going to subtract 6x, subtract 4y squared, and add 15x squared. So I'm going to have 8xy dy dx is equal to, and let's put that 15x squared minus 6x minus 4y squared. So I'm not starting with the negative. And then all I have to do from here is divide by that 8xy. So dy over dx is equal to 15x squared minus 6x minus 4y squared over 8xy. All right, let's look at example 3. Oh, this one has a sign, and it looks like we're going to have to do a chain rule here because we've got the sign on the outside and we've got an x plus y on the inside. So the derivative of sine is cosine, and then I'm going to multiply that by the derivative of the inside. So the derivative of x is 1, and the derivative of y is 1, but because it's a y, I've got to do dy dx. And that's going to be equal to, well, the derivative of 2x is just 2. So what I need to do here is I need to distribute my cosine into this parentheses. So I'm going to have the cosine of x plus y times 1, so just the cosine of x plus y, plus the cosine of x plus y times that 1 dy over dx. So cosine of x plus y dy dx, and it's equal to 2. So I need to subtract this cosine over. So I have the cosine of x plus y dy dx is equal to 2 minus the cosine of x plus y. And then the last thing I'm going to do here is divide to get that dy dx by itself. So that cancels out, and I'm left with dy over dx is equal to 2 minus cosine of x plus y over the cosine of x plus y. So that green right there is our answer. All right, let's look at number 4. So this one I have 4x plus 1 is equal to cosine of y squared. So once again, I've got a chain rule with my outside part, and then the y squared is the inside part. So when I take the derivative of the left side, the derivative of 4x is 4, and the derivative of 1 is 0. So 4 is going to be equal to, and let's do our chain rule. So the derivative of the outside, the derivative of cosine, is negative sine. So I'm going to have negative sine of y squared, and I'm going to multiply that by the derivative of the inside, which is the y squared. So the 2 comes down, and I have 2y. And because I just took a derivative with a y, I've got to do dy over dx. So you only put that dy dx when you actually take the derivative of the part that has the y in it. Okay, so let's clean up how we're writing this. And let's do purple this time. So 4 is equal to, I'm going to bring that negative 2y in front. So negative 2y sine of y squared with the dy dx. And the reason I'm writing it that way is because now all I have to do is divide by that negative 2y sine of y squared. So that goes away. So I have 4 over negative 2y sine of y squared is equal to dy over dx. But I can simplify this because I've got a 4 over a 2, and I can go ahead and bring the negative out in front. So a negative 2 over y sine of y squared. And I'm just going to put the dy over dx in the front because that's how we usually see it. So dy over dx is equal to a negative 2 over y sine y squared. Okay, let's look at 5. All right, so I'm going to start with the derivative of the 5x squared. So that squared is going to come down, and it's going to be 10x minus, and right here I've got a chain rule. I've got the e, and then the exponent is my inside part. So the derivative of the outside is e to the 4y squared. And then the derivative of 4y squared, well, the squared comes down, so it's going to be 8y. And then I got to put that dy dx because I took a derivative with a y. And it's equal to, well, the derivative of negative 6 is just 0. So I'm looking at 10x minus 8y e to the 4y squared dy over dx is equal to 0. So I'm going to move my 10x over to the right. So I have negative 8y e to the 4y squared dy over dx is equal to negative 10x. And then I'm going to divide by that negative 8y e to the 4y squared. So that cancels out there, and I'm left with dy over dx. And if I'm looking right here, I've got a negative 10 over a negative 8, so I can simplify that. The negatives are going to cancel out, and it's going to be 5x over 4y e to the 4y squared. And that is my simplified answer. Okay, so let's look at 6. For example 6 right here, my outside is that natural log, and the inside is the 4y cubed. So the derivative of natural log is 1 over whatever's on the inside, so 4y cubed. And I'm going to multiply that by the derivative of 4y cubed. So the 3 comes down, and I have a 12y squared. And I've got to have a dy dx because I just took a derivative with a y. And that's going to equal, well, the derivative of 5x is 5, and the derivative of 3 is 0, so it's going to equal 5. So let's clean it up a little bit. If I have a 12 over a 4, that means I'm going to have a 3. And then if I have a y squared on top and a y cubed on bottom, that's going to be over a y. And then I'm going to have dy dx is equal to 5. So what I can do here is to get rid of that 3 over y, I'm going to multiply both sides by y over 3. So the y's cancel, the 3's cancel, and I have dy over dx is equal to 5y over 3. And that is my derivative. We've got 2 more that we're going to look at. And they're going to take this implicit differentiation and apply it a little bit. So let's look at 7. This one says find the equation of any tangent line for x squared plus y squared is equal to 4, and x is equal to 1. So the first thing that I'm going to do is I'm going to plug in that 1 for my x and see what y values I get. So I'm looking at 1 squared plus y squared is equal to 4. So 1 plus y squared is equal to 4. I can subtract 1 from both sides, so y squared is equal to 3. And I'm going to take the square root. So y is equal to plus or minus the square root of 3. So what that means is I have the point 1 square root of 3, and I have the point 1 negative square root of 3. So that means that I'm going to have 2 tangent lines. So now let's find our derivative so we can find the slope for those tangent lines. So I'm going to come and do that in purple over here. So if I've got x squared, the derivative of that is 2x plus, well, y squared, the derivative of that is 2y, and then I've got to put a dy dx on the end, and it equals 0. So I'm going to subtract my 2x from both sides. So 2y dy over dx is equal to a negative 2x. And then I'm going to divide both sides by 2y. So dy over dx is equal to, those 2's cancel out, a negative x over y. So now that I've found my derivative, I need to plug in my green highlighted point and my blue highlighted point. So when I plug in my green highlighted point, I'm going to get dy over dx is equal to a negative 1 over the square root of 3. And I don't want that square root in the denominator, so I'm going to multiply top and bottom by the square root of 3. So I get that dy over dx is equal to a negative square root of 3 over 3. And when I plug in my blue point, I'm going to end up with dy over dx is equal to negative 1 over negative square root of 3. The negatives cancel out, and then I'm going to do the same thing. Multiply the top and bottom by the square root of 3. So dy over dx is equal to the square root of 3 over 3. So now I've got my point and my slope for the green and the blue point. So my green tangent line is going to be y minus the square root of 3 is equal to a negative square root of 3 over 3 times x minus 1. And my blue tangent line is y plus the square root of 3 is equal to the square root of 3 over 3 times x minus 1. So I have two tangent lines here, and that is what they look like, the green and the blue. So there are my two tangent line answers. And 8, the last problem for this video. We're going to find d squared y over dx squared. So that is our second derivative. And we need to find it in terms of x and y. So let's find our first derivative. If I've got y squared, the 2 comes down in front, so I have 2y. And because it's a y, I've got to do my dy over dx. Then I've got minus 3y, so that's going to be minus 3. And then dy over dx, because that part had a y in it, and I took the derivative of that y. And it's going to equal, the 2 comes down here, so I'm going to have 4x plus, and the derivative of x is 1. So I can factor out my dy dx, and I'm left with 2y minus 3, and that's still equal to my 4x plus 1. And then I'm going to divide by my 2y minus 3. So dy over dx is equal to 4x plus 1 over 2y minus 3. And now I need to find the second derivative. So I'm going to take the derivative of this whole green part right here. So when I take my derivative here, it's going to be d squared y over dx squared is equal to, and it's a fraction, so I have to do my quotient rule. So low, 2y minus 3, times d high, so the derivative of 4x plus 1 is just 4, minus high, so my 4x plus 1, d low, well the derivative of 2y minus 3 is 2 dy dx, and that's all over my low, which is 2y minus 3 squared. But we're not done here because it says in terms of x and y, which means I cannot have that dy dx there. So what I'm going to do is I'm going to plug in my dy dx. I know it's equal to 4x plus 1 over 2y minus 3, so I'm going to plug that in right there. So while I'm doing that, I'm going to go ahead and simplify. 4 times 2y gives me an 8y. 4 times a negative 3 is minus 12. And then it's going to be minus a 4x plus 1 times 2, and I'm going to plug in my dy dx, which is 4x plus 1 over 2y minus 3. And that's all over my 2y minus 3 squared. So d squared y over dx squared, our second derivative. So now we need to clean this up because we can't have a fraction within a fraction. So what I'm going to do is I'm going to multiply the entire top by 2y minus 3 and the bottom by 2y minus 3. So if I've got 8y minus 12, I can write that as 8y minus 12 times 2y minus 3 minus my 4x plus 1 times, well, the 2y minus 3 cancels out there, so I just have 2 times the 4x plus 1. And that's all over, well, now it's 2y minus 3 cubed. All right, so we can clean this up a little bit. And we're not going to multiply all these out. I'm not going to make you guys simplify that. I know that you can FOIL this out and do all of that. So what I'm just going to do is say dy or d squared y over dx squared is equal to 8y minus 12 times 2y minus 3 minus 2 times a 4x plus 1 squared over 2y minus 3 cubed. And we can just leave it like that. I know that you guys know how to FOIL it all out, so I'm going to trust that you guys can do that. Okay, so that's it for this video. Make sure that you do your Go formative that goes with this set of notes. So there is a 3.4 Go formative that you guys need to do. And you guys have a good day.